Welcome to your daily dose of statistics. I am Professor Charlie Collins. So today we're going to be digging into some descriptive statistics. And more specifically, we're going to actually go through a series of lectures covering central tendency, measures of distribution, and then the normal curve. After we're done with this series of lectures, we will move on to inferential statistics. But first, this first lecture is dedicated to understanding central tendency. And so in this lecture, we will be talking specifically about mean, median, and mode. And so let's take a moment to define what central tendency is. Central tendency measures the average or typical case in a distribution of scores. And so there's different ways to do that, right? Because we have our different levels of measurement, right? We have our interval ratio variables, we have our nominal variables, and we have our ordinal variables. And each type of measure is specific for each type of variable. And we'll dig into that in a moment. So let's first talk about mode. The mode in a distribution is the score that occurs most frequently. Mode is primarily used for nominal data, right? So again, just to refresh, nominal data are things where you have, are variables where you have categories, right? Where each category is mutually exclusive. So it's typically something like race, or gender, or sexual orientation, or what neighborhood you live in, or what city you live in, right? All of these are nominal variables. So let's take a quick example to understand what the mode is, for an example. So in this case, let's say we asked a handful of people what their religious denomination is. And we came up with, we found people who are Protestant, Catholic, Jewish, atheist, and other. And so the mode in this, thinking that the mode is the most frequently occurring score, which one would you think it would be? Now, if you said Protestant, you would be correct, right? Because in this case, the most people were Protestant compared to everybody else. Now, the reason we don't use mode, or I should say typically don't use mode when we're using interval ratio data, is because it can skew what our interpretations are. So let's say that I own a car dealership. And I have a variety of different people at my car dealership, right? Say we have 30, let's say it's a huge dealership, and we have a lot of different people who sell cars. And so I'm just I'm interested in finding how many sales each person has per day. And as we can see here, we have an interval ratio data scale. Right, one car sold is 1, so it's an interval ratio scale, and 0 means something. And what we see here is some people, 2 people have sold 10 cars, 6 people have sold 9 cars, 5 people have sold 7, so on and so forth. And so with mode, what this is asking is, if we're looking at mode with regard to an interval ratio data, we're not looking necessarily at central tendency. What we're doing is we're identifying the frequency of a particular score. So in this case, we have 9. So what this is telling us is most people sold 9 cars that day. So this doesn't necessarily tell us central tendency, right? Because central tendency or something like the average would be something different. So mode is something very particular here. It discusses the it identifies the most frequently occurring score. Now let's take a second and talk about the median. The median is a different way to identify the average or most typical score. So the median is the exact center of a distribution. And oftentimes you'll hear this on the news media, for example, where they'll say average or median home prices in a particular area are, $200,000, for example. And what they're doing there is they're not taking an average, they're taking literally the exact middle score. This is primarily used with ordinal data, but it can be used with other types of data as well. So income is one that is often used, and you might ask the question, well, why would we use median with income when income is an interval or a ratio score? Oftentimes we use median with something like income because income is often very highly skewed. And what that means is most people sit at the lower end, and there's a few people, like Bill Gates, for example, who have billions and billions of dollars, right? Whereas most of us make less or around $100,000 a year. Most of us make less than $100,000 a year. So those few people really skew the distribution. So when you have a skewed distribution like this, you're going to want to use the median score. So what we do here, right? Let's say we have 7 different people, and we get their yearly income, $40,000, ranging all the way down to $15,000. And we literally take the exact middle score, right? So it's not the difference between 40,000 and 50,000. It is literally the middle score. So in this case, the score right in the middle, or the 4th score out of 7, is 30,000. And so in this case, we would say the median score for this distribution of scores is $30,000. Now you're probably asking yourself, well, what if you have an N of 8 instead of an N of 7, or a sample size of 8 instead of a sample size of 7? What you do in that case is you take the 2 middle scores and you average those. So in this case, what we have is $30,000 plus $25,000 divided by 2, right? We're taking the average of these 2 scores. And what we would say here is the median is $27,500. So that's the difference when you're working with an even number of scores versus an odd number of scores. When you're working with an odd number of scores, you take the middle. When you're working with an even number of scores, you take the 2 middle and average them. And again, this data is used, something like the median is used most often with ordinal data, but it can be used with interval and ratio data if the data are skewed. Now let's talk about mean. Mean is probably the most common central tendency measure, and the mean is the average of all scores in the distribution, right? So we all know average, the average height of a group of people, for example, or the average age, right? It's the average of all the various scores in a distribution. And so the formula for this is x bar. So whenever we see this x with a little bar over the top, we call that x bar. That is the representation of the mean. So if you ever see x bar, that is your mean representation. Then we have our sigma xi sub I, and then we have n. Sigma x sub I is the summation of all scores. So in this case, x is a score and I represents a hypothetical case or a hypothetical person of that score, who has that score. N is the number of cases, right? Our sample size or our population. So let's use an example here. So let's go back to the car example, right? So we have 8 different people, and we're interested in the average number of sales in a day, right? That way I can report to the bosses. This is on average how many sales we have a day. And as you can see, it's a wide distribution. You have some people who sold a lot that day. So person A has 10 sales, whereas person H has 0 sales, right? So you have a fairly broad distribution. And so what we want to do here is we want to take all of the scores, so all of the x's, and sum them up, right? That's what that little sigma is to sum up all of the scores. Then we want to take that, and it's a little dull there, but the denominator here is an 8, and the 8 is the sample size, which is our n, right? So we add up all the scores in the numerator, divide by the denominator, and what we come up with is a score of 5. So what we can say is, on average, associates of our dealership make about 5 sales a day, right? But again, that's not completely telling us the whole story, because as you can see, some people are doing much better than 5. Other people are doing not as well as 5, right? But on average, our group sells 5 cars a day. And this is, to be very clear here, the mean is typically used for interval and ratio data. However, we'll talk about this in a second. So these are our basic understandings of central tendency. This really formulates the baseline of moving into inferential statistics. We'll be using the mean primarily for inferential statistics, and also univariate and multivariate statistics. So the mean is an important thing to understand and to grasp. So it's necessary to understand which measure of central tendency to use for what variables. And so this little table here identifies which measures of central tendency are the most appropriate and under what conditions. The dark bolded yeses identify the most appropriate measure of central tendency. The non-bolded yeses identify that measure of central tendency is appropriate for those scales. No's mean you do not want to use that for that scale. It's completely inappropriate. And then the yes with a question mark, that one's sort of interesting, because particularly in the social sciences, a lot of social scientists will utilize ordinal scales in the form of Likert scales. And what a Likert scale is if you've ever done a survey online, for example, and it'll ask you something to the effect of, to what level do you agree with the following statement, right? And they'll give you a statement, and it's strongly disagree, neutral, agree, or strongly agree, right? Those are ordinal scales. But in the social sciences, oftentimes we will analyze those using the mean instead of the median, right? So the lengthy piece of this is that even though the mean may not be the most appropriate for ordinal, social scientists often use them. So that is our quick overview of central tendency. And again, this is part of a series of small lectures discussing descriptive statistics, and particularly the central tendency, variance and dispersion, and the normal curve. So we will be moving into those in the next couple of lectures. And after we're done with those, that will finalize our lectures on descriptive statistics. And that is your daily dose of statistics.